Hello and welcome to the third video of the Diachromy overview series. I'm Paul, I'm a cinematographer, one of the persons behind the creation of Diachromy. And today we're going to talk about the 3D transformations tools, which are probably the most complex but also most powerful tools for crafting a look. I strongly recommend you've seen the first videos of this series where we set up a project, learn about the basics of Diachromy. And they're a good starting point because you usually want to start with 1D transformations, which are the topic of the second video, before diving into the 3D transformations. As you can see, I have an ACCCT workflow that's properly set up here, and all my demo footage is properly color managed. So what do we mean when we talk about 3D transformations? In the previous video, we've talked about 1D transformations, and we've seen that these are transformations that will operate on the red, green, and blue channel independently. There's no interaction between these three channels in 1D transformations. This is not the case with 3D. So the cube that I've just enabled shows you all the possible color points of your working color space. So here we're displaying this cube and it's an ACCCT color management workflow. So we can see from 0 to 1 all the possible color values in the ACCCT environment. In the cube you have one line for the red values, one line for the green values, and one line for the blue values. You can rotate it here with these settings here. You can rotate it and you can see how it's displayed, how it works. From 0, 0, 0 here to 1, 1, 1 here, there's a diagonal that crosses the cube and that is a neutral gray line. So of course here I'm not doing any transformation, so my cube is a perfect cube. There's no modification of it because this is just a default state of the plugin. So if I load a preset only on 1D transformations, what will happen? So let's load a contrast here. Okay, and even with color tone curves, as you can see, I can modify it any way I want, change the contrast, the offset, do some color tinting. So whatever the modifications I do here on the contrast, on the color tone curves, you can do any kind of transformation you want in 1D. The resulting volume will always be cube-like or cube-shaped. It might be a bit rectangle-based, it might be smaller, it might be bigger, it might be deformed, but it will always be cubical-ish. There's no way to make a complex transformation of that cube with 1D transformations, and that is why it's called 1D transformation. And 3D transformations are not limited to this kind of reshapes. They're later on, when we review each operator of the 3D tools, we will see specifically what they do on the cube, but just for a preview of that, if I load a preset on the 3D transformation, so let me reset the tool, just show the cube, and I'm just going to load a preset on the vertex transformations, just to illustrate my point. So as you can see, we get much more complex transformations than we had with the 1D tools. And this is one of the features of Diachromy that makes the looks more wholesome, more complex, and ultimately more visually interesting. So let's get to it. The main group of 3D transformations is called vertex transformations. You can see that there are settings that are the same for the 6 vertices, 3 primary and 3 secondary colors. There's also a set of global settings that will have an impact on the whole cube that we will see later on. And finally, there's a section called Selective Color Guidelines that help you target smaller parts of the cube that are specifically interesting when doing look development. And we will see that in a later part. Once again, as it was the case with the modules, it's advised to start from top and work your way through the bottom of the settings. Of course, you're going to end up doing back and forth and modifying dynamically your look, but it's a good entry point to start from the top, from the global settings, and then work your way down. For now, let's look at one of the vertices, the red vertex, for instance. So you get access to 2 kinds of operators. I would classify that in 2 sets. One would be the simple operators. They address one characteristic of the image. They're pretty self-explanatory. For instance, the hue offset here, the saturation offset, or the brightness offset. And you also get complex operators that will take different characteristics of the image and make them interact. That would be the case for color density or color boost or lossat, for instance. Simple operators will allow you to modify one aspect of the color. So when I offset the hue, as you can see on the cube, the transformation that results is not linear. It's it has some kind of a round, curvy aspect to it. This is actually very interesting. It's because most of our 3D transformations are performed in a spherical environment. We manipulate the cube and the colors in a spherical set of coordinates. The result of such transformations usually look more organic and more visually pleasing in the end than their counterpart in a linear set. That is one of the key aspects of why diachromist 3D transformations are very powerful. So you'll get the same round, curvy aspect in transformations when you move the saturation here or the brightness. As you can see when I manipulate these sliders, we are working on 1 out of 6 areas of the cube. Of course, the vertex transformations divide the cube in 6 areas that are connected to each vertex. The mathematical operations are designed to be as smooth as possible at the edge of these areas. In most cases, when you try and get an image that's visually pleasing, that's interestingly looking, it's not breaking at the edges of each of these areas. Of course, if you go very, very far in the values, there's always a way in look development to break something. But in most cases, you'll get very smooth transitions between these 6 areas. And that's because we took extra care while designing these tools to ensure the continuity of the math in the way we split the cube in 6 areas. And it usually gets bad looking before you get breaks between the 6 sides. Complex operators now, so there are 5 of them here, from color boost to bleach. Color boost will increase the saturation of the color by focusing mainly on the low saturations and by almost not affecting the highest saturations of the given color. So when you look at the cube here, you can feel when I increase the color boost that the values are pushing from the heart of the cube, but are not expanding the size of the cube that much. And that's because the main modifications of the color boost happen on the low saturation, so deep down within the cube. And if you go below 1, it gets pulled inside, but the high saturations are maintained at their place, or almost at their place. Color density will allow you to brighten or darken the colors depending on the saturation. The higher saturation will be affected more by the settings, so you can darken the high saturation of the colors. As you can see here, if I decrease the color density, these parts of the image get darker, while the low saturated part of the image retain their brightness. This is very well illustrated by this kind of chart, because in this chart, for each color, each column represents a color, and it's the same hue and different values of saturation. So you can see that if I start sliding the color density, then these high patches will be affected way more than the low patches. The color density is actually a behavior that comes from the film world. In film, when you have a high saturated patch, there's a highly concentrated area of dyes in the layers of the film, and that will block more light coming in to form the image. So in film, traditionally, if you have a high saturation, you get a darker area. And this allows you to emulate that. And if you go with the slider in the other direction, you actually lighten up the high saturation more than the low saturations. The low sat operator allows you to increase or decrease both saturation and brightness of some very specific parts of the image, and that is the low saturated shadows. We've implemented that feature because we realized that when we're doing 3D transformations for a look, and we have a very strong look that really gets a bit intense or twists a lot the image, the result may be very pleasing on the overall image, but you get these areas that we're talking about, the low saturated shadows, might get a bit too affected by the transformations. And so you get an overall look that is very pleasing, very committed to the target look that you're trying to achieve. But these low saturated shadows can be a bit too toned down and lose a bit of life. And these areas are located, for instance, in the skin tones. That can be the shadow parts of the skin tones. And losing life, losing light, losing saturation in these parts can be a bit problematic in the look development. So you can see by loading most of our built-in presets that we rely a lot on the low sat operator to compensate for that effect. For instance, if we load the vision emulation, you can see on the face of this character here that if I cut the low sat and I put it back to 0, my global look is really committed, is really holding together, and there's a very visually interesting way to shape the color of the image. But the shadow part of the face is a bit toned down, and if I restore the low sat from the preset, then I get to bring back this life in the face. Next operator is the saturation roll-off. The saturation roll-off allows you to enforce a limit on the amount of saturation that the image is going to be able to reach. So that means that when you set up a saturation roll-off, whatever you do with the saturation after that, you won't be able to exceed a certain amount of saturation in the image. Here I set up some saturation roll-off, and even if I push hard on the saturation, of course, you can see that it comes on the cube, it comes and it bumps against the limit that we've set up, and it won't go over that limit. Of course, in between 0 and the limit, it changes. The saturation still has an effect, so you can shape it, but you really enforce that limit. And it's not like a clamping hard limit, it's a roll-off, so that really helps the data to land on that limit in a smooth fashion. Finally, the bleach operator allows you to desaturate and lighten the bright and saturated colors of the image, and that shifts them towards the white. It's a derivation of the bleach bypass effect, a staple of a 35mm processing, without the contrast aspect. Once you get started and experiment with these operators, you'll quickly figure out that some of them work very well in pair because of the way they interact with the color and each other. Color density, for instance, works very well in pair with saturation. When you enable color density and you try and darken the saturations, the highest saturation of the image, you get a result that's pretty visually interesting in the high saturations. But you might be a bit frustrated by the way the low saturations are rendering in the image. And once you increase the saturation, you can get the low saturation to a place that's more visually pleasing. And low saturations, especially in the red vertex, are zones of the image that are very pleasing to the eye because it's the skin tones, for instance. And when you increase the saturation, but you have a strong color density negative offset, then your high saturations are taken care of by the color density, and they get darker as they increase in saturation. And this way, you get the best of both worlds. You get the low saturations at the right place with more life in the skins, for instance, and a richer skin palette. And you get deeper, darker high saturations. And that overall behavior increases the color richness of the image. So we found that it's a pretty common move to find the right balance between, for instance, color density and saturation. This covers the vertex level operators. As you understood now, all these operators are identical for the 6 summits of the cube. If you get to global settings, you get access to some of these sliders that are the same than in the vertex, but they will operate on the whole cube. So, for instance, the saturation will affect the whole cube, and you'll get this round, curvy feeling that we talked about during the vertex example. And you get access to saturation, color boost, color density, and low sat. They work the same way as we just seen, just on the whole cube. You also get access to 2 blends. The global blend is a classic blend that will allow you to blend the whole 3D transformation on your image. So if I load a preset, for instance, Earthy Pastel, I can blend my whole 3D transformation on the image from 0 to 1. And I can get beyond 1, which is a very fast way to increase the effect of the 3D transformations you're applying. If you're satisfied with the overall look, but you want to go a bit farther in the intensity of the effects, you don't have to go back in each vertex and on all the sliders of the 3D transformations. You can just increase the intensity of the effect by going over 1. The other blend, the frequency blend, has been designed as a solution to reduce the noise that is sometimes amplified by a strong look development. That is an issue that is not uncommon to look developers because whatever the tool you use, depending on the quality of your signal, the camera data you got, the intensity of the transformations you're applying to the image, the look might amplify the noise that's already existing in the data. And our frequency blend allows you to filter out a part of the fine details of the image so that they are not processed by 3D transformations. And if they're not processed by 3D transformations, the fine details, which is where the noise lies, will not be amplified. So if I go on a low light footage, for instance, that image, if I apply the earthy pastel again, if I zoom in here, I can see without transformation, here is my noise pattern. And if I load, for instance, earthy pastel, I can see that my color transformations are amplifying the noise here. And if I increase the frequency blend, as you can see, the noise pattern is almost not amplified anymore. So we really managed to filter out the noise in our transformations. This tool is based on a spatial analysis of the image. So it has to be assessed shot by shot because some patterns could interact wrongly with the frequency blend. But it's still a very efficient way to handle noise amplification when doing look development. Of course, it doesn't get integrated in a LUT export because it's not a pixel-to-pixel transformation, it's spatial, but it's a great tool for final grading. Last group of the vertex transformations, let's look at the selective color guidelines. The selective color guidelines are the final step when shaping 3D transformations of your look. They focus on smaller subsets of the cube that have a special interest when doing look development. It's going to be 3 areas for now. The greens, so mostly everything that's leaf, trees, vegetation related, the skins, and the lips, a subsection of the skins. As we've seen before, it's good practice to work on these smaller subsets after having done most of the major 3D transformations, because the major transformations will have an effect on these smaller subsets, and then you'll be able to fine-tune these smaller subsets within the bigger transformations of your 3D. It's the same logic than with the low-sat operator that we've seen earlier. Basically, your 3D transformations have a huge impact on the whole cube. And here in the selective color guidelines, you're going to be able to work against maybe some of the undesired effects of these major transformations, but that have an overall look that you like. For the greens, we offer an enhancer that will allow you to affect more volume of the cube to the green color. And that means that when you increase the green enhancer, you spread the greens more widely towards the cyan on one side and the yellow on the other side. So you give more space to the green colors, which means you'll get more nuance in the green environment. Obviously, the cube has a finite volume, so if you give more space to the green, you'll get less space for the cyan and the yellows. So as with most look operations, it's an arbitration. You have to set up a compromise between the volume of the greens and the volume of the neighboring colors. But it's usually interesting to give a bit more volume to the greens because it takes a lot of place in the real world, and so it takes a lot of place in the image. Once you've enhanced your greens, you can also offset the center of the greens to go more towards the cyan or the yellow. This will offset the major tint of the greens while retaining some nuance, especially if you've enhanced the greens before. Skins and lips have the same operators. You can offset the density of the skin, you can offset the hue of the skins, and you can offset the saturation here. So let's say your look enforces a very low saturation behavior in the global way. You might want to end up here and boost up a bit the skin saturation so that you don't lose too much of the life in the skin tones, but you remain consistent with your overall look. If you try and get a low saturated look through the vertex transformations only, if you want to retain some life in the skins, then you'll end up adding some saturation back to the whole red and yellow vertices, since the skins are really right in the middle between the red vertex and the yellow vertex. And if you compromise in favor of the skins, then you won't get a good enough compression of the saturations with the red and the yellow vertices. And this is why selective color guidelines are usually set up at the end of the process. We advise you not to focus on the skins at first because you can fine-tune it after through the selective color guidelines. And so you need to focus on your major moves in the 3D transformations through the vertex transformations and the global transformations, and then fine-tune it here. Okay, so we wrapped up the overview of the vertex transformations module. It's clearly the most complex, but also the most powerful module in diachromy. So I really advise you to play with the built-in presets and with presets that you might get from other sources, and keep the cube visualization open if you want to see exactly what an operator does on the cube. We have implemented tooltips on each operator, so you get information about what the operator does in the tooltip. And sometimes there are extra information in the documentation website. All right, let's finish this deep dive into the 3D transformations by having a look at the effects module. The idea behind the effects module is to have standalone effects that will emulate behaviors that we like from, I don't know, film references, specific film looks, specific emulation strategies, or other kind of filtering behaviors. As of today, we include an emulation of a bleach bypass process, which is very close to the bleach bypass spatial processing of the film world. The main setting would be the bleach strength, which will act as expected by removing color and increasing contrast, as you can see on this image. You get a lot of control over it because you can decide which level of chroma you re-inject into the look, so you can decide to get back some chroma. And you get two blends, the highlights and the shadows, which allows you to decide whether you have a full effect on the highlights, and you can completely disable this bleach bypass on the highlights, as you can see. And it works the same for the shadows. So once again, the parametric aspect of it all allows you to create a faithful emulation of the bleach bypass behavior on a negative or on a positive film, and it also lets you create a more modern version of this iconic film look behavior. The effects module is also covered by two blends, the global blend and the frequency blend, same as we've seen earlier. And this effects module is meant to evolve over time. If we find some new filters, some new types of processes, we will include them in these effects in future updates. So that's it for the whole 3D transformation deep dive. Thank you for sticking with me through this. It was, I think, worth the time because it's really one of our most powerful modules that we've seen. In the next videos, we'll do a look breakdown of some of the presets we built in the Dichromy. Thanks for watching, and see you in the next videos.